Alright, hello everyone. My name is Paul Kanyuk, and I'm going to continue along with my Katana and RenderMan demos. This week focusing on AOVs, as well as light path expressions, a little bit of lighting, and hopefully denoising. This demo is a request from some Film Academy students where I'll be teaching a two-day class next week, and they were curious about these topics. Alright, so we're going to pick up with the still life that I used in my procedural shading demo. This is a very simple Katana scene, and this should have the basic elements that we can use to illustrate these concepts. Now the first thing I'm going to cover is AOVs for creating matte images that kind of isolate certain parts of the scene. And just to remind you guys what scene we're working in, if we go to the viewer, look through the main cam, this is our scene. And I'm going to kick off a preview render just to remind you guys where we're at. So while this is rendering, let's talk about what an AOV is. That stands for Arbitrary Output Variable. It basically means RenderMan can output pixels not just for the beauty, but for many different passes at once. I like to use the term pass because that implies kicking off a new render. An AOV is not a render. It is just extra data that comes out of a single render. Theory, it's almost free to have AOVs. The bit of overhead from driver as well. Of course, disk space is one of the big concerns. And what our scene looks like. Let's start by seeing if we can pick out these images, this plate, and this into AOVs where we can isolate them. We want to do fix up, or we want to change the color of the oranges in post, or maybe make the table a little darker, or maybe blur out the background. So to do that, first thing we're going to do is create a new RenderMan shading node and find, I believe it's called the matte ID pattern. If we wire this pattern into our shaders, we should be able to output our matte ID AOVs. I'm going to call this PSN matte ID. Alright, and then we can take the output, the result ID of that, and wire that into every surface shader we have. So we have 3 in this case. The orange, we connect that to the utility pattern. This is basically a little hook where we can put, basically connect a pattern object to our shaders that can just do certain utility functions that don't necessarily relate to the look of the shader. We just kind of want this to run in each shader. Great, so that's part of it. But really what we need to do is actually set some RenderMan attributes that give basically information in the scene that will drive what this matte ID goes into. So let's take a look at the table for now. Under RenderMan statements attributes, we want to create a user attribute named a certain way that will drive this. I always forget the name of this attribute, so excuse me. I have another version of this scene where I'm going to kind of just quickly look ahead and see what did I name this attribute again? Matte ID. Okay, so it's actually not too bad. So anyway, that's what we're going to do. So we need to create a user attribute named matte ID. The way it seemed this was done in the demos I saw before was using an op script. We've used op scripts, I think, we use them all the time at work. I'm not sure I've showed these in the demo, but basically these are just little nodes that can set attributes and do various things to your scene using Lua. My apologies if you guys don't know Lua. This might seem like magic, but to really get the full capability out of Katana, you're going to write lots of these guys. So this op script, we're going to do create a group builder. I guess we'll call it GB equals group builder. And we're going to have that run on our table. And this group builder will basically create what's called a group, which is a collection of attributes. We're going to need to create a user attribute that has both a string and float value associated with it. So we're going to say gb.set, and then we're going to create a new attribute called type, and we're going to call it string attribute, and I guess this will be a color. yes, this matte ID is going to be a color. Let's see if that works. If you get a red error here, you know you've typed some syntax error. For instance, if we add an extra parentheses, it'll go red. So as long as you're not seeing red, it's at least valid Lua. And I don't use Lua very much. I use Python mostly my day-to-day, so I always forget some of these things. All right, so then we're going to create another attribute called, or another part of our group called value, and that will be a float attribute. And basically what this is going to be is the color that we want the table to be in our matte ID AOV. So let's just make it red. And this float attribute could be, array of any size. You have to say it's a 3 float vector. All right, and now that we've done that, I think there's some final call where we actually create the group. And I don't use group builders that often, so I'm going to look ahead. Interface.setAdder, group builder. Man, so this syntax is fun. All right, so to actually set an attribute, you do in a op script, you do interface.setAdder, and then the path to where the attribute is going to be. And again, we want under PRMan statements, attributes, and user. So let's do PRMan statements, attributes, dot user, and I believe again it was called matte ID. And then we're gonna set the value to gb.build, I hope. Alright, let's see what happened. Yay, we got a matte ID. And here's what I mean by a group. This matte ID is a group that contains 2 attributes, a type and a value. The type is color, and the value in this case is 100, and that is set on the table. So that is going to be picked up by that matte ID pattern and be output into the AOV accordingly. That was a lot of boilerplate, but you really just need to figure that out once. I'm going to call this OS matte ID table. One more detail. The matte ID, if we go to this pattern, you actually see there's several matte textures. This allows us to actually create a whole bunch. It looks like up to 8 of these matte images where you can have different colors in each one. So it's important that we don't just set matte ID. I believe we actually want to have a number next to it. So I'm going to call that matte ID 0. And then we'll call that one matte ID 0 there. Great. And then, so matte ID 0, we could use, as many colors as we want. Typically, I think you just use, RG or B or combinations. It probably just, 3 per image to keep things easy. So let's now let's do the plate in this still life. And we'll also have that be matte ID 0, but rather than having it be red, we'll have it be green. All right, and we have to change where we're applying that rather than the table. Let's clear that out. Let's drag in the plate. All right, so this plate should now have this other matte ID. And now for the oranges, we could, put them all as green in matte ID 0, or we can jump ahead and have another matte ID image for the oranges. So we'll do that. Might as well, since we have a lot at our disposal. It's up to you how you want to carve up this mapping. I'll call this matte ID 1, orange A. Let's clear that out. Drag in orange A. And let's make orange A red. And also change this from matte ID 0 to matte ID 1. Now let's do orange B. And for those watching this on YouTube, this is where you're probably going to start zoning out, checking your phones, checking your mail. Don't worry, you're almost done. One more orange to deal with. And hopefully we'll see some pretty pictures soon. Orange C. Orange, you're glad I named it orange. Make it green, also matte ID 1, and clear the path out. And finally wire that into our network. I don't believe that took. One cool thing in Katana, in theory, you can hover over and actually get it to connect. So there we have it all connected. So orange C. Oh, looks like we forgot to do B. We forgot. A lot of things can go wrong when you're repeating the same thing over and over. All right, A, B, C, different colors for each. Great. And once you have all these set up, it's starting to clutter up our network. I recommend just doing Control G and to make a group out of it, and then we can call this group Mat Setup. Great, so that's the start. Let's go save our scene, but that's not enough. That's we actually need to create what are called new render outputs that will basically give us either new channels in our beauty paths or extra images that contain that matte data. So for that, you do a PRMan output channel define. I guess we want it to be type varying color, and hopefully, let's see if I remember the convention, just matte ID 0 would be the name of that. And again, I tend to abbreviate these things. So instead of PRMan output channel define, I do POCD matte ID 0. And we'll do another one for matte ID 1. It's just, again, per matte ID, not per color we've chosen. So there'll be fewer of these guys. All right, now that we've declared the channel, we need to say, all right, where does the channel go? What image should it be part of? That's where we do a render output define. We tend to do these things in pairs. First, the PRMan output channel define, which kind of declares the variable. Then the render output define, you have more details about what image it's going to go into. So I'll create one of these, call it rod for render output define, matte ID 0, and we should so one of the most important things to set is the channel, and fortunately, since we've already declared that channel of matte ID 0, it's as simple as just grabbing it there, and we can change the output name to matte ID 0, and let's go ahead and create another one called matte ID 1. Set that and change the name up there. And now we're almost ready to see some pretty pictures. First, the next thing we need to do is go to render settings. By default, the interactive outputs on render settings just says primary. We want to do it all, which means we're going to actually see all of our AOVs when we render. So in theory, now if we go ahead and do a preview render, drag that into our monitor, and go from this drop down, we should also see matte ID 1, 0, and matte ID 1. And check it out. Yeah, we got a different color per orange, as well as a different color for the table and the plate. So this should allow us to do all the kind of compositing tweaking we might want to do in this simple scene. In a larger scene, you got to be a little more careful how you set these. You might want to do something. All glass has one, matte ID, or all metal has another. Skin, eyeballs are a classic thing. You always need to get the character's eyes, teeth, and mouth kind of in a separate AOV, because that's the kind of thing that you end up tuning. The director usually likes to noodle with. But anyway, that's the basics of matte ID AOVs. But it doesn't stop there. There's a lot of things you can put in AOVs, including different lights in different AOVs, using a technology called light groups. So that will be the next task, and that will get us a little more involved in lighting. So this demo will not just be AOVs, it'll also be lighting. So let's see if we can do this real quickly. So right now we just have one light in the scene, an environment light. To really show off how you can put different lights in different AOVs, it's useful to, at least add a second light. So if we find our gaffer right here, oh, by the way, here's another good chance to make a group. I'm going to do Control G on these guys and call this matte outputs. So we have the setups and the outputs there. All right, let's collapse our network a little bit. All right, very quick lighting demo. So let's go to our gaffer. I think it'd be cool if we had a rim light. Just sort of, this almost looks like really staged photography for this beautiful plate of fruit. It'd be cool if we had a light there. Also, just while we're on it, This is a torus. I probably would have used a disc or something, but I really don't like that the hole in the torus is creating a little extra detail where I don't want. One fun thing I'll show you guys, if you want to ever darken part of a light, including an environment light, you can create what's called a blocker to kind of arbitrarily darken part of its contribution. And that's just an awesome thing that you can do that, you know, in case you don't know, here's how to do it. So if you select that dome light, you can go to Add, Light Filter. A light filter is an object that actually will filter paths of light. So it might have like a location in space, and all light that goes through it might be attenuated in a certain way or colored or something. There's a whole bunch of different types of light filters. They're actually shaders, and if we go into the material, we can how do we, if we go to material, add shader, oh, light filter, there we go. So under add shader, go to light filter, and then we can find a PXR blocker light filter. That's the most common. And the blocker will have a bunch of parameters under it. And these rod shapes will just basically show you by default where the darkening will happen. So if we go to our viewer and we expand the scene graph to find these locations, you'll see, maybe let's go to wireframe. I don't even know how to see wireframe, but suffice to say the light filter's at the origin. And the easiest way to probably do this is enable live rendering, kick off a live render, and start playing with the parameters of this. So I'm going to right click, go to live render, drag that under, and let's see what we got. So actually already, if we compare it to the previous one, since the blocker was added at the origin, it's already kind of doing what I want. But just to show you what the effects are, since that was maybe a little too magical of a demo, if we go to this radius right here and make it 5, you know, we've just really increased that quite a bit. 1 is probably good. If anything, actually probably want to make it smaller, 0.5. I don't want to make it so obvious what I'm doing, and then maybe increase the edge, which is sort of like a penumbra edge to the blocker. I mean, this is all fake. We are totally changing physics here. Actually, maybe a little wider. Cool. Yeah, I just wanted to get that little bit of orange brightness there. So there we go. And this is, you know, if you're a lighting TD, this is the kind of work you're doing a lot, setting up blockers and shapers and all these fun things to change your lighting. So that's as far as I'll do for the environment light. What I really wanted to do was add an additional light so I can show you guys light group AOVs. All right, let's go ahead and save. And to do that, let's go back to our gaffer and add. So I want the rim light to always be opposite camera and just shining along the edge of it. I'm actually not much of a lighter. I don't know if this is what a real lighter would do, but I think it's kind of fun to give this a try. So we're going to do what's called create a light rig. This is an object that we can constrain and that we can basically use to keep the light facing camera. And let's go to our viewer. And I'm going to go to perspective cam so that we can more easily see what's going on. Alright, so for the light rig, well, first, before I do too much, I'm going to add, let's do a rectangle light. And we want this rect light, let's expand that. There's our rect light right there. We want that to face camera. So, I really should figure out how to get wireframe going. Options, wireframe, there we go. Cool. Alright, great. So let's get that wireframe to face the camera. So to do that, we select our rig, and we will enable an orient constraint. And for the target of that, we'll just drag in main cam. Boom. So now, hopefully, this will stay oriented to camera. Now, right now, it's actually facing away. So I believe we can do maybe a 180 rotation on the rig. No, we can't because we actually just set an aim constraint. So instead, we can actually go to the light itself, the rectangle light, and do a 180 rotation. Cool. So now it's facing away from camera. We just want to actually kind of put it behind the spheres. So let's go ahead and maybe move it down. Oh, other way. -5 in Z, maybe not that much, maybe just -2. And let's bring it up. Whoops, I hit spacebar instead of Alt. Too high. 2. And let's also rotate it a little bit. Not that way. Maybe it was that way. Other way. -25. Maybe -15. Cool. Alright, that's roughly a rim light facing camera. You know, this is the kind of thing, maybe that looks good. I don't know. Let's go ahead and go to the monitor and make sure we have live render enabled. Do a save, and then let's right click and go to live render and see if we can do some lighting here. Alright, so offhand I don't really see much contribution, but let's go ahead and maybe increase the intensity and the size till we see something and then see if it's in the right place. So we go to the material, make our intensity 4. That's not doing much. How about let's scale it and increase the size. Maybe make the scale 5. Alright, now something's happening. Cool, that's quite a hot rim light there. Let's maybe make that intensity back down to 1 or 2. Maybe 1. Cool. And or not maybe 2. And again, we can, since we're making light group AOVs, we can always balance this out in comp. The other thing I might want to do is, right now it's looking the exact same color as the sun. I want to maybe make it a little bit different. I'm going to enable color temperature and maybe take it down to 3500, which gives you more of a warmer, like artificial light color. So that's actually, I think we'll call that final lighting. So brilliant. So now that we have 2 lights, let's go over how to do light group AOVs. So for that, we select the light, and under advanced, under light group, we can type something like rim light group. And then for the dome, we can give it a name like env light group. Cool. Alright, and now we don't need to set any RenderMan attributes anymore. It's actually just a matter of setting up the output channels and the PRMan channel output defines and the render output defines to get this working. So let's do another POCD node. And we're going to change the type to color. And I'm going to call this POCD and env light group. Now I believe the syntax is LPE, and then I believe, so interestingly enough, I think we can just do env light group, the name of it, or you can actually put a diffuse underscore or a specular underscore in front of it, which is a way you can sort of separate out which bounce of light you want for each. We're going to go over denoising later, and for that we almost always want to separate out diffuse and specular, so I'm just going to go ahead and call this diffuse env light group. And LPE stands for light path expression. This is a sort of we'll see a little bit later when we do denoising exactly what the symbols mean, but this is kind of just, I think, an automatically generated keyword that will represent all the diffuse light that came from that light group contribution. And then we're going to do another one for the rim light. Oh, we also probably, while I'm going to call that diffuse. Sorry, that was the one I was going to call diffuse. For this one, let's now do specular. And finally, let's do the same for the rim light. And then I think we're probably far enough that I think we'll save denoising for a different lesson. For now, let's just get this light group working. Connect that in. And for this other one, we just change env to rim. And yes, you should name the node, not just the attribute named. Otherwise, you're going to get very confused what's doing what. Rim light group. Whoops. For some reason that didn't take. All right, cool. So I think we have all of our PRMan output channels. And like, yay, we're ready to render. Not quite. Don't forget, you need your ROD nodes, your render output define nodes. Yep, a lot of boilerplate for this kind of stuff. But once you've done this a few times, you can do some copying and pasting. And for this one, again, if you have it set up, you should be able to just go ahead and select your channel there. And then for denoising, as we'll learn later, we'll want that to be color type raw because we'll need floating point numbers on that. So you might as well do that now. And I'll call this diffuse and light group. And I'll call that ROD. And you know the drill. We're going to have to do this a few more times. 3 more times. Specular, again, this is where you guys are going to check your phone. But it's a live demo. I got to do it. I have no choice. You know, if I was getting paid to do this, maybe I would edit this after the fact. But no editing for you guys. This is a one-take demo. I either get it right or I don't. All right, diffuse and light group. Sorry, this is the rim light group. And you know, I've been so zealous about changing names, I forgot to actually change the channels. And this is perhaps the most important thing. Sorry, we want LPE rim light diffuse, and in this case we want LPE specular env light. And one final rod. This is going to be specular rim light. Specular rim light group. Specular rim light group. Okay, I think we have done all the necessary boilerplate to get those 2 lights going into different AOVs. One thing we could do is go to our render node and check our outputs. Wow, look at that. So we got 2 matte images, and then we have diffuse and spec for both our lights. Now we could right click and go to preview render, and that's my roommate coming downstairs to say that we need to head out. So we're almost done with this demo. Let's see if we have all of our AOVs. Yes, it's the 4th of July, and here I am making this demo for you guys. All right, so there's our diffuse environment light, our specular environment light, our diffuse rim light, our specular rim light, as well as all of our matte IDs. That is all the AOVs you might ever want, hopefully. So let's go ahead and save this, stop this demo. We got to drive or take a lift to the city and go see some fireworks covered by clouds and fog, maybe. San Francisco. All right, thanks, guys. Bye.